example, we can actually see couple of common subsequences or consecutive subsequence. One consecutive subsequence we can find is 99 and 100, which is at these two positions. And second consecutive subsequence we can find is actually 1, 2, 3 and 4. Now in the what we were doing in the brute force is we were checking at every single position that what would be the longest common subsequence we can find. The thing is we can only find the longest common subsequence from the first element of the start of this consecutive subsequence. Same goes over here, that whatever the subsequence we can find at this value number 100, the subsequence that we can find at value number 99 would always be greater than whatever we can find over here, because this by itself is already a subsequence. So we are going to use this logic. Like over here, if we put this 3, 2, 3, 4, we will only find the consecutive subsequence of length 2. But this 2, 3, 4 would be of length 3, and this 1, 2, 3, 4 would actually be of length 4. So we can only find the maximum consecutive subsequence at the start of the any subsequence, not somewhere in the middle. And the only way to check that whether we are at the start of the subsequence or not is by just checking one very simple condition, that at any point we check that whether the exact value before that value, like one value before the value we currently are at, if that exists, which means that we are not at the start of the common subsequence. Let's take it by an example over here and let's see that what would be our approach. So first of all, we are going to be at this position 100. We are going to check that whether this 100 is a start of any consecutive subsequence or not. So we check that whether in this given num set does the value 99 exist. Now we know that 99 exists. So because 99 exists, 100 cannot be at the start of the common consecutive subsequence. So we are going to ignore this case. We don't have to do anything with this 100. We come up at 99. Now we come up at this 99. We check that whether there exists a value before 99. So 98, does it exist in this num set? 98 does not exist, which means that at 99 we can be at the start of any common consecutive subsequence. So we start a subsequence at 99, and now we will initiate our logic. And in our logic we are simply going to check that from this 99 how many consecutive numbers we can reach. So we are going to check that, okay, 99 by itself is a common subsequence of length 1, so we know that. Now from this 99 we are going to check that can we reach value number 100. So 100 we can reach, and because we are using a hash set, we can do all the operations in constant time, so we are not adding any strain in our time complexity. Now we can find the value 100, so we can reach 100, which means that whatever the longest common subsequence longest consecutive subsequence we found, we will increase its value to 2. Now again we will try to see that whether we can find 101. Like 101 does not exist, which means we would break out of over here, and the longest common subsequence we have found up until this point is actually of length 2. Again we are going to repeat the same process. So now we are at this position 4. We check that whether 3 exists in this set or not. So 3 exists, which means we ignore this 4. Now again we are at 200, so we check that whether 199 exists. So 199 does not exist, which means 200 can be start of the any consecutive subsequence. So we again check that whether 201 exists, but 201 does not exist in this given example, so we ignore this 200 as well, because the longest consecutive subsequence we find at this value number 200 is always going to be 1, and we already have a value that is greater than 1. Again we check at this position 1, that can 1 be start of any consecutive subsequence. So we check that whether the 1 minus 1, so we check whether 0 exists in this example or not. 0 does not exist, which means 1 can be start. So now we set our current subsequence to value number 1, and now we check that from this value 1 how many other values we can reach to. So first we check that can we reach the value number 2. Yes, we can reach value number 2 because 2 already exists. So we update whatever the current subsequence we can find to 2. Now from this 2 we check can we reach 3. Again we can reach 3, so we will update the current value to 3. Again we check that whether from this 3 can we reach 4, and yes we can reach 4 as well. So again we will update the value of our 4 value of the current subsequence to 4, and from 4 we check whether we can reach 5. So 5 we can't reach, which means we are at least able to reach this 4. So we are able to see that the longest current subsequence we have found is 4 and previous value was 2. So we will update this, so this will become 4. And now again we are going to check the same thing for this value number 2, so that for value number 2 does 1 exist and 1 exists, so we will ignore this. Again we check for 3, does 2 exist, 2 also exists, which means we are going to ignore this 3. And now since we have reached the end of this hash set, so we are going to reach whatever we found in the as the longest consecutive subsequence, and this would be our answer. Now if we calculate the time complexity would actually be big O of n in this case, because we are only iterating over the entire input just once through this hash set. So this is a very efficient time complexity. And if we see the space complexity is actually big O of n, because we will have to create this additional numerical set, and we are going to store n memory for that. And let's see the coding. I will be showing the hash set solution in this code, but I'm going to post both the codes in the comments so you can check it out from there. So first of all, we are going to check that whether we are given an empty list or not. If that's not the case, first of all, we are going to create a hash set. We are going to name it num set. Now we'll run a loop across the given input, and we are going to store all the values to our hash set. This is going to do two things. It's going to eliminate all the duplicates values, and it will only add unique entries in the hash set, because hash set has a property that does not allow us it to store duplicate values. Now we are going to create a parameter to store the longest subsequence, and we are going to initialize it with value 1. Now we are going to run a for loop across the given num set. So initially we are going to check that whether we are starting from the middle of any longest consecutive subsequence. If that's the case, we are going to ignore that number. So if this condition is true, we are going to continue and go to next element in the loop. If this is not the case, we are first of all going to mark the number we are at as current number, because this is the beginning of any longest consecutive subsequence. We are also going to create another parameter called current sub that is going to take care of the current maximum consecutive subsequence we can find, and we are going to initialize it to 1. And now we are going to put a condition that while our hash set contains the current number plus 1, while this condition is true, we are going to increase the number, and we are also going to increase our current subsequence. And after this loop ends, we need to check that whether we have found the longest common subsequence or not. So once this loop ends, we should have our answer in the longest sub variable, so we can simply return that. Let's try to run this code. Okay, seems like our solution is working. Let's try to submit the code. And seems like our solution works pretty well, and it is faster than a lot of other solutions. I will also post the sorting algorithm solution as well, so you can check it out from the comments. Hello friends, I'm a cloud solutions architect at Microsoft, and my aim is to empower every single person to be better at technical interviews. Keeping with that goal in mind, today we are going to do a very interesting LeetCode problem called first missing positive,
And if we see some of the popular companies who already asked this question, there are companies like Amazon, Microsoft, Google, Apple, IBM, TikTok, Hudson River Trading, ByteDance, Twitch, Facebook, Uber, and Snapchat. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode hard problem and also very well liked problem on LeetCode. Basically, we are given an unsorted integer array called nums, and we need to return the smallest missing positive integer. So the problem statement is really small and easy to understand. The tricky part in this problem is that we are being asked to solve this problem in big O of n time with a constant extra space. So time complexity has to be big O of n and space complexity has to be big O of 1. So this is the difficult part that we are trying to achieve. Now first let's try to understand this with few examples that what does this problem is asking us to do. So in this case we are given a numbers array, and in this case the values are these. Now we are trying to find the first missing positive number. Okay, now what is the first positive number? First positive number is going to be 1. Then what is the second positive number? It's going to be 2. What would be the next one? It would be 3. Now in this case, since 1 and 2 both are present, 3 is the first missing positive number, so we need to return 3 as the answer. If we take a look at the second example, again in this case we have 1 present, but we do not have 2 present. So because 2 is going to be the first missing positive integer, so in this case we don't even need to check for all the remaining ones. 2 is going to be the answer that we need to return. And same goes with this example. In this case, since we don't even have 1 as the answer, we are definitely going to return 1 as the answer because 1 is the first missing positive number. Okay, so the problem statement is really easy to understand. Now let's see that what could be the possible different approaches we can take in order to solve this problem. Well, the first approach that comes to our mind is a brute force approach. In the brute force approach, what we are going to do is we will try to find the first positive number. So first positive number is going to be 1. We will see that whether 1 is present in this or not. Okay, so 1 is currently present. So now we will move on to 2. 2 is also present. So then we will move on to 3. So value number 3 currently is not present. So we can say that 3 is the first missing positive number and we will return 3 as the answer in this case, right? But the thing is, what is the issue with this brute force approach? Well, the issue is quite simple. Time complexity is actually going to be big O of n square, which is disastrous. So we will have to do something better than this. Let's try to find another approach and see if we can do something better. So say for an example, suppose this is the given input. The idea is that if for this given input, if we somehow sort this input, we would actually able to do something better. So let's just see the sorted result. All we need to do is go to the first positive integer. So in this case, first is 1, 1 is present over here, and then move to all the other elements until we find a place where the next element is missing. So in this case, we can clearly see 3 is missing. So 3 is again going to be the answer for the sorted approach. So sorted approach works better than the brute force solution. But the issue with the sorted approach is that from given input, in order to generate the sorted array, it takes us the time complexity of big O of n log n just to generate this sorted approach, and then we will have to iterate over it once. So the thing is, this time complexity is still more than what we want. So this approach is also not going to work. Let's try to see some better approach. Okay, now before we go to the next approach, first let's try to make things much easier to understand. Suppose if we are given any input, and if all the values are starting from 1, only positive values that are incrementing in sequential order, what would happen in this case? What would be the first missing positive in this case? Well, definitely the first missing positive in this case is going to be value number 5. Why value number 5? Because currently the given input n only has 4 characters and all the characters are like 1, 2, 3, 4. So the minimum possibility is that the value could be 5, or it could be any single value from starting from 1 to 4. So basically all the values that are concerned of us is that the first missing positive will only be between the given n plus 1. So from 1 to n plus 1 is the possibility where the first missing positive value lies. In any other values are no use of us. So say for an example, if we are given input n where the values are such as like -1, -6, then +8, then 1, 2, something like this. If this is the possibility, definitely the first missing positive in this case is going to be value number 3. But the thing is, since here there are only 5 values, the first missing positive number can only lie between the values of 1 to 6, nothing more than that. So if that is the case, why are we even concerned with all the values that are not between 1 to 6? If say for an example values like these three, we are not concerned with them, and I already explained you why we are not concerned with them, because we are actually going to use it in one of our next approaches. So say for an example, if this is the input we are given, previously for the sorting and also for the brute force, what was the issue happening? The issue was happening that if we want to search that whether value number 1 exists inside this given input or not, it was causing us a lot of time. So what if we speed up this process? We can actually speed up this process by creating a hash map. And what would we do inside this hash map is that at any given position, we will first try to identify whether 1 exists or not. And 1 is not, if 1 is not existent, definitely we are going to return 1 as the first missing positive. That is going to be our answer. That is going to be the most simple case scenario. But if 1 is present, then we are guaranteed that the value of first missing positive is going to be between 2 to 6. So any value that does not lie between the values of 2 and 6, we can simply denote their value as 1 inside our hash map, and then we will do something tricky with our hash map. So let's apply this logic to our hash map. Let me quickly draw the hash map from given input. And by the way, for any particular value, this is going to be the key, and its subsequent value is also going to be same, except for these three values where the value is going to be 1. So this is the hash map we have been able to generate from our given input n, where the key is the same value as the values inside our array, and its subsequent value we have done some modification, and all the other positive values, they are equal to whatever their subsequent values are. Now all we need to do is, we know that the answer could only be lying between 1 to 6, nothing more than that for the first missing positive. So we will run a loop starting from value number 1 to 6, and we will try to see that whether all the values between, like including 1 and 6, between 1 to 6, are they present inside this hash map or not as key. And we would be able to do this in constant time, because that is one of the property of the hash map, and that is going to make our lives much more easier. So first we will try to see that whether 1 exists inside the hash map or not, and definitely 1 exists over here. So we can simply go to the next element. So we will check whether 2 exists or not. 2 also exists, so we can simply go to the next element and we will check whether 3 exists or not. Since 3 does not exist inside the hash map, we can immediately say that 3 is going to be the answer that we need to return. And this is a very good approach. This solves a lot of our problems that we were facing in terms of time complexity. Why? Because it takes big O of n time to generate this hash map. Okay, so in order to generate that hash map, it takes big O of n time, and then in order to run this loop and to come up with the answer that whether the value exists or not, that also takes big O of n time. So if we see time complexity, basically we have been able to complete this problem in big O of n time, and this is going to be great. This is a wonderful result, and any single interviewer would be more than happy with this approach. But the thing is, in this problem, if we see space complexity, this is where the problem lies for this approach, because space complexity in this case is also going to be big O of n. Why? Because we are creating an additional hash map. Meanwhile, we are explicitly told that we need to complete this in big O of 1. So can we do that? And the answer is yes. Okay, now let's see that what would be the optimal solution where we also do constant space complexity in order to solve this problem. The logic we are going to keep are same, that any values that are too great or negative or 0, we are actually going to convert them to 1. Now let's see that in this given input, how many elements we are given. We are total given 8 elements, which means that the answer has to lie between 1 to 9 for the first missing positive integer, which means any value that does not fall in this range, we will actually have to change it to value number 1 inside this given input. So let me create a new array. This is the new array we generated. Now let's do a quick recap. Basically, we first check that whether 1 is present or not. Since 1 is already present, we iterated over this given input array, and from that we converted this for all the values that were not falling between the values 1 to 9. Okay, now we are going to do things a little bit interesting way. What we are going to do is, since we already know that 1 is present, which means we are not worried about value number 1, we are simply going to iterate over this values whenever we find a value that is not 1, a value that is not 1, which means, say for example, we find this value number 5. So we will go to its subsequent index. So in this case, we will go to index number 5, and whatever the value is, we will just convert it into negative. Nothing more than that. This is a very simple approach. So let's just quickly do another array, and we will follow the methodology I mentioned. In this case, the first value is 5. So because first value is 5, we will try to find subsequent value and convert it into negative. So this becomes negative 3. This is value number 1. So we don't need to do anything. Again 1, again 1, and again 1. So since these 4 are 1, we are not going to do anything. Now this value is negative 3. So because this value is negative 3, we will go to third index, because this used to be a positive 3 value. And remember what I said, anything but 1. So in this case, we will go to this value and convert it into negative as well. So this becomes negative 1. Now we are okay. Again, this value is 1, so we don't need to do anything. This value is plus 2, which means we will go to second index and convert it into negative. Awesome. Now, what are the things we have been able to dictate? We already know that 1 is present, which means that the answer has to lie between the values 2 to 9. Now in this case, since we will start iterating over from value number 2 to all the values remaining inside the given input array, because we already know that 1 is present, so we don't need to do anything. And now all we need to do is to check that whether that value is negative or not. And the moment we find the first positive value, that index value is what is going to be the first missing positive integer. Yes, this is the whole logic. Now in this case, since this is negative 1, this is negative 1. So these two values, we have been able to dictate that why they have been turned into negative 1, because their subsequent values were present at some point inside the given input array. That is why we converted them to negative 1. So we can ignore these two. For this particular value number 4, this is a positive value. The moment we identify a positive value, this can only remain positive if there was 4 nowhere to find in this given input. Say for example, we found that this value was 4, then we would have definitely converted this to negative 1. But the thing is, we did not find anything, and that's why we left it as positive, and we have not been able to find 4 as the first missing positive. So we need to return 4 as the answer. And this is the optimal solution. If we see time and space complexity in this case, the time complexity is actually going to be big O of n. Why? Because first of all, it takes big O of n time to generate this, and then it takes big O of n time to find the first missing positive integer. So we are satisfying on that aspect. And if we see space complexity, well, apart from using couple of variables, we are not using any additional space, because all of these things are being done on the given input array nums. We are not creating an additional new array. This is a very good time and space complexity and a great approach to solve this problem. Because if you see in this problem, what are all the things we have been through? We first saw the brute force solution, then we saw the sorting solution, then we saw a hash map solution, and then we saw the optimal solution. So we actually went through 4 different approaches, and every single time we started to improve upon something. And this is what any single interviewer would want to see, that how you have been able to do things. And that is why FAANG companies love asking this question. So now let's move on to the coding. So for the given input, first we are going to check that whether 1 is present or not. If 1 is not present, we are simply going to return 1 as the answer. Okay, now the logic we are going to apply is that any single value that is not falling between our given range, we are going to convert it to value number 1 inside the given nums array. Now all we need to do is we will need to go over the given input array where we have already changed the values with 1. And anytime we identify the value is different than 1, we will go to this array and change its subsequent index location to a negative value. Okay. Perfect. So now with this loop, we have been able to convert all the values to the negative value wherever we find a subsequent positive value, any value apart from 1. Okay. Now all we need to do is run a for loop from int I is equal to 1 to the last element, And we simply need to check that at any given position, if we identify a positive value, we are simply going to return that index character, and that is going to be the answer. Now we are also going to check for a couple of edge cases as well. Somehow if we are not able to return the answer, which means we have found the perfect sequence, so we will need to return the last value inside our first missing positive integer, which is going to be n+1. And this is the whole code. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs 100% faster than all the other solutions, which means this is a great solution. And I will be posting this in the comments so you can check it out from there. Thank you.
So now the next topic we are going to talk about is very closely associated with arrays. It's called sliding window. Essentially, we are going to have a subset in the current array that we are going to slide across the array to fulfill some conditions. Let's try to see a visual explanation before diving deeper into the more questions associated with that. So at a conceptual level, sliding window is very straightforward. Basically, we have given a sort of an array and we are trying to find a piece of information that is located somewhere within this given entire spectrum of array, but we don't know what. So it can be an example where we are given to find some value associated with a subset of array. Let's say that this array contains total n elements and we are being told that find a subset k such that uh, essentially maybe they all sum up to a target. So that can be an example, or it can be like a smallest substring or a largest substring that means something, or that we need to find some value associated with that. So in all of these cases, let's say that if we are given an array and we are trying to find a subset of an array of size 3, where for each of the subset basically we need to find that what is going to be the maximum sum of this subset. If we take the brute force approach, we would basically end up calculating every single possible different arrays or different outcomes, and we would have created bunch of different nested loops in order to achieve that. Now this is very expensive. A better way to do it is that we can clearly define that this is going to be the window that we are going to slide over in the existing array, and this window is initially residing between these two elements. And let's say that some of these three elements turns out to be 30. Let's say each of these values are 10, 10 and 10. Now next value we currently have is, let's say, 5. So in this case, instead of just recreating all the calculations or reiterating over these two values, because we already know that they are part of the window, we can just simply change the position of the window and now only include these three elements. And now all we need to do is, from the previous sum of the existing window, we can just reduce whatever the value this was. So 30 minus 10, because we eliminated this element from the window, and then add this element, so plus 5. So this sum is going to be 25, and we can say that okay, this sums to 25. Then same way for next window we can repeat the same operation. And this is an example on how changing window can create some interesting results. Now there are some very popular questions associated with this, and one of them is my favorite question, that is the best time to buy and sell stocks. So that would be coming in our most popular lead code problems that we would be doing. So let's try to solidify our concept for the sliding window now. Today we are going to do best time to buy and sell stocks lead code problem. This question has a very real life practical application. That is why it is very famous amongst IT companies as an interview question. If we see some of the companies where I want to work at who have already asked this question, there are companies like Amazon, Microsoft, Facebook, Bloomberg, Google, Goldman Sachs, Apple, Uber, Snapchat, Yahoo, ByteDance, DoorDash, eBay, Netflix, and Reddit. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is the LeetCode easy problem, and you can see that it has been one of the most liked problems on LeetCode. If we try to understand the problem statement, basically we are given an array called prices, where any single value inside this given array indicates the price of that particular stock and on that particular day. Now we want to maximize our profit by choosing a single day to buy the stock and choosing a different day to sell the stock sometime in the future, and our aim is to maximize our profit. So if we try to see it with an example, suppose this is the example that we are given, where we are given 6 different prices for a stock and we are told that we need to maximize the profit. So I have drawn it on a graph over here, so it makes things more easy to understand. And we know that at any given position it shows that what is the price of that particular stock. So initially the stock price on first day was price 7. Now on the second day the price fell down to price 1. So we are not making any profit, we are actually going down and we are losing the money. But if we see over here, so this day it's 1 and this day the price is 5. So if we see over here, between these 2 days we actually made a profit of $4. Again price fell next day to $3, and then again price rise to $6. So over here we lost $2, over here we again made some gain of $3, and at the end the price was 4. So over here again we lost $2. So the thing is, if we just do it like this, we don't get the maximized profits. Why? Because we are only seeing that what is the difference between every single day. But if we see that if we do something, if we buy the stock on this particular day, which means that we are buying the stock when the stock price is at 1, and if we sell the price when the stock price is at 6, so which means if we sell when the stock price is at 6, we can actually make a profit of $5. This is the answer we need to return, that this is the maximum profit we can make based on these stock prices. So let me show you that what would be the brute force approach, and then I will show you that what would be the optimal approach. So for the brute force approach, one thing we can do is that we take every single position of a buy and sell price for these given stocks, which means that we make every single pair. So first of all, we see that if we buy the stock at price 7 and we sell at price 1, again we sell at price 5, again we sell at price 3, and so on and so forth, what is the maximum profit we are getting. And we will create a variable called profit, and we will keep track that what is the maximum number we have found so far. Once we are done with this value number 7, we would ignore this case, and then again we will repeat the same thing with value number 5. So we start buying, so we start that our buy price is at value number 1, and again we start checking all of the comparisons that what would be the profit, and eventually we would find a pair where buy value is 1 and sell value is actually 6, which means that we would gain profit of $5, and then we will return this as our answer. Like, this solution would work as expected, we will get the desired result. But the thing is, this is not the most optimal approach. Why this is not the most optimal approach? Because if we see the time complexity in this case is actually going to be big O of n square. Why n square? Because for any single entry we will have to take a look at every single entry in the remaining array, and we will iterate this process. So that is why it is a very time consuming process, and we need to find a way to do something better. And let me quickly show you that what would be the optimal solution in this case. So for the optimal approach, what we are going to do is we are actually going to see that when do we get the maximized profit. We only get the maximized profit when we buy at the lowest value and we sell at the highest value. So this is the logic we are going to apply over here, that we are going to buy the stock at the lowest value and we are going to sell the stock at the highest value. But the thing is, it is not as easy as finding like the maximum value and the minimum value, because in this case maximum value is actually 7 and minimum value is actually 1. We don't need to get the difference of these two values, because if we do that we will get an answer of 6. But the thing is, we are actually dealing with stocks, so we can only buy stocks in the past, which means that if we decide to buy a stock over here, we can only sell it afterwards. We can't sell it to some value in the before. So that's why that is one thing we need to keep track of, that we have to make sure that this linear property of buying and selling is maintained in this case. So what we are going to do is we are going to have a variable called buy, and that is going to keep track of what is the minimum value we have stored so far. And we are going to see that at any given moment, whatever the minimum buy value is, if on that particular day we try to sell a stock, what is the profit we are getting. So let me quickly draw three variables over here. So we are going to have three variables called buy, sell and profit. Now first of all, we are at this position number 7, which means that we are buying the stock at 7 and we can't do anything about it because we don't have any way to sell it. So we will start with the second position. So now on the second day, the stock price fell down to 1, which means that if we have already bought this stock at value number 7. If we try to sell it at value number 1, it really does not give much progress. But one thing we can do over here is that because today the stock price is actually low, we can reduce that whatever the buying price is from 7 to 1. So we will do that. So now the buy price is actually 1, and we are not selling anything, or we are not doing anything again. Now the next day the price of the stock is 5. So we'll try to do that. Okay, what is the 5 minus 1, which is the minimum price we have bought stock so far, and 5 minus 1 is actually 4, which is the maximum profit we have made so far. And we don't need to update this buy value because we have already bought it at a lower price than whatever the current price of the stock is. Now we will move on to the next value. So next value, the stock price is actually 3, which means 3 is still greater than value number 1, which means we don't need to update this value number 3, but we will have to check that whether we are making any greater profit or not. So again, we will do 3 minus whatever this buy value is. The buy value is 1, so 3 minus 1. So the current profit we make is actually 2, but the thing is 2 is actually less than 4, which means we don't need to update the profit we have made so far. Now again, we will ignore this case. We will move on to the next value. So the next value, the stock price is actually at 6. So stock price is now at 6, and now again we will do 6 minus 1. So 6 minus 1, selling price would be actually 5, and because this is 5 and this profit is actually greater than whatever profit we have achieved so far, so the current maximum profit we have made so far is 5. Now again, the stock price is at 4, so again the selling price on this day would be 4, and we don't need to update the buying price because the buying price is already at 1, which is lower than 4. And now we will do 4 minus 1. So 4 minus 1, if we do, we still make profit, but this profit is only $3, and $3 is actually less than whatever the maximum profit we have made so far. Now we are at the end of our loop, and now we don't have any more values to iterate over inside the given array, which means whatever the result we have stored inside the maximum profit variable, we will just return that. And in this case, we will return answer as 5, and this answer would work perfectly fine. This is like the most desired answer we need. If we see the time and space complexity, in this case the time complexity is actually big O of n. Why big O of n? Because notice that we are completing everything in a single iteration. And in terms of space complexity, for the space complexity, we are not actually using any additional space apart from storing couple of variables, so that's why space is also constant. So that's why this is a very good approach. We are solving this in big O of n and big O of n time and big O of 1 space complexity. So first of all, we are going to initialize a variable called min, and we are going to give it the first value of the given price. We are going to create a variable called profit to note down the maximum profit we can achieve, and initially we are going to mark it as 0, and then we will update the value inside our loop. So now we are going to run a for loop across the given array. Now inside the given loop, first of all, we will check that whether we need to update the value of min or not. So we will check that if the current min value is less than whatever the value of I is, then we will update the value of min. And also we will check that whether the current profit we can make by selling the stock on that particular day comparing with the min value, we will choose the maximum profit we can. And once this loop ends, we simply need to return the whatever value we have stored in the profit variable. Let's try to run this code. Okay, seems like our code is working as expected. Let's submit it. And our code is actually pretty efficient. It runs faster than a lot of other solutions, and I would be posting this code in the comments so you can check it out from there. Thank you.
Hello friends, hope you are having a fantastic day today. So once again, we are going to do an awesome LeetCode problem that has been asked at tons of companies. So without any delay, let's get started. So the LeetCode problem we are going to solve is called permutations in a string, and we can see that this is a LeetCode medium problem and also extremely well-liked problem on LeetCode. The problem statement is very straightforward, that we are given two strings s1 and s2. Now we need to check that if any of the permutation of s1 is present inside the s2 string, then we need to return true. If that is not the case, we need to return false. Now let's try to see this with an example. Say for an example, we are given s1 is equal to value a and b, and we are given a string s2. Now
there can be two permutations and combination of A and B. It's A and B itself, or either B and A. Now we can see that in this string S2, BA is actually present. So because it is present, we can actually return this as true, saying that a permutation of AB or string 1 is actually present inside the string 2. Now let's take one more example. In this case, we have BA as partial permutation of this string 1, but we does not have anything like C, or we have, in this case, we have AC, but there is an X in between. So we do not have any direct permutation of string 1 present inside the string 2. So in this case, we can return false. Now, even though we have A, B and C, all three present inside the string 2, but they are not present together. So that is the main problem. So now let's see that how can we actually solve this problem. And the number one approach is very simple, brute force approach. So for the brute force approach, what we can do is we can take string 1, suppose the values are A, B, C, and then we can take string 2, suppose the given values are once again B, A, X, C, D, Z, something like this. So we can take every single possible permutations of S1, and then we can check that whether those are in any given moment present inside the string 2 or not. So this is going to be very inefficient approach. So we need to do something better. Now the question is, in any given case, suppose the string 1 is ABC, then what are the different permutations and combinations possible? In either case, you can notice that instead of keeping track of all of these permutations and combinations, we can say that currently for the string 1, we actually have 3 different characters, and the frequency of each of these 3 characters is actually 1 time. So we have A present 1 time, B present 1 time, and C present 1 time. So at any given moment inside the string 2, if we identify that, suppose string 2 is, let's say that X, B, A, C, D, Z, something like this. And if we identify that amongst any given moment, we can identify these 3 occurring in any subsequence in the same amount of frequency. So I'm not talking about order that A has to come before B has to come before C. I'm talking about the frequency, that at any given moment we want to check that whether all 3 A, B and C are present in the same number of occurrences, which we can see over here, that if we take a look at this portion, we can actually see that we can also make another frequency map that contains once again characters A, B and C, and each occur 1 time. So because there is a match in this regard, we can actually say that this string 1 is actually present inside the string 2 as one of the permutations or combinations. So this is the approach we are going to use. Now, in order to use this approach, we actually need 2 things. Number 1 item we need is that we need a way to create a frequency map to contain that how many times any single character is present inside the given string 1. Then we need to create the window of that exact same size and then iterate over every single possible windows of the string 2. And once we do that, all we need to do is just compare 2 different frequency maps. So what are the efficient ways for us to compare frequency maps and create frequency maps? Well, there are actually 2 ways. So number 1 way is that we can actually use a hash map, because in the hash map we know that it is a key value based pair data structure. So as a key, we can set up the character, and as its subsequent value, we can set up the frequency. So once we have the hash map or frequency map for string 1, we can do that. And same way, the existing window we have for string 2, we can actually create a very similar frequency map for the string 2 as well. So that is option number 1. The option number 2 is that we actually create an array with 26 characters, and we create 2 arrays. So one array is for string 1, one array is for string 2 for that specific window. And let's assume that in string 1, the value is ABC. So we can mark ABC as 111, and for rest of the characters, we can mark them as 0. And this can be also an efficient way for us to check that what is the frequency and how many times it is present. So same way for S2, we can also create an array. So both ways would yield the same space complexity. So what I'm going to do is in the example, I will explain it to you using hash map, but in the code we will use the array method. Okay.
Now let's try to understand the approach I'm suggesting using couple of examples. So suppose we are given our string map is equal to value ABA, and we are given our string 2 as the values A, B, C, D, E, F, E, X, then A, B, something like this. Okay. Now we know that what is the approach we are going to do. For string 1, we will have to create a hash map. So let's quickly create a hash map. The idea is that string 1 hash map is going to look very simple, that it only contains 3 characters that are A and only 2 characters, A and B. Now A is present 2 times and B is present 1 time. Now we have the hash map for string 1. Now for the string 2, what we are going to do is that we are going to create an exact same size window, and then we are going to keep sliding that window over from left to right. And using that approach, we would be able to solve this problem very easily. So let me tell you what we are trying to do. So initially this string 2 does not have a hash map. So let's create a frequency map for string 2 as well. Okay. And I'm marking 3 values. So now let's see. Okay. Currently this one does not have anything. So we are going to consider these 3 values as our first window. Now we are going to create a frequency map. And the idea is that we can keep on comparing the 2 frequency maps, or if you don't want to create 2 maps, you can actually start deducting values as well. But in either case, you will have to remember that what was the original state. Okay. So that's why for our simplicity, I'm creating 2 maps. So now for this A, we have this A and it is occurring once. Once again, we have this B, it is also occurring once. And then once we have C, that is also occurring once. But if we compare these two, then we can see that A and B is partially there, but C should not be there. And we are still missing one A. Okay. So in this case, this is not the correct approach. So now we will have to migrate our window one step forward, which means previously we were considering this ABC. So now we will get rid of this A and we will treat as if this A is currently no longer needed. And now we are going to be dealing with this particular window. Now the thing is, when we are dealing with this window, the question is, do we need to create another same window for this new portion? The answer is no. We can actually do something very simple. The idea is that whatever the value was present over here, we can actually get rid of that value because we are moving to the next step inside our sliding window. And then whatever the new value is, we can simply add that new value to the hash map. So now we are going to get rid of A. And we are going to add one other value D, and we are going to mark its frequency. So D is also present once. But once again, this window also does not yield us the correct result, and these two are still not equal. Okay. So now we will have to consider this window. So once again, we will keep on repeating the same process. We will get rid of B. Once again, we will get rid of B. We will include value E again. So now E is present one time, but also this window does not work as well. So now we are also going to get rid of this value number C. Now C is no longer present. But now we are going to include value number X. So X is present one times, but once again, this is also not correct. So we will get rid of D and we will have this window to consider. So now we are going to get rid of D and we are once again going to add value number A one times. Now, once again, this is not the correct approach. So we will once again get rid of value number value number E, and the new value is A. So because new value is A is already present, which means we do not have to add A again. So we can just increase the value of A second time. Now, currently we are considering this window, but this is also not the correct window. So we will also get rid of this one. We will kick X out and then we will add value number B. So adding value number B would allow us to add one more value B inside over here. And now this is our final window. But in the final window, we can see that both string 1 hash map and string 2 hash map are same. The frequency of character occurring is exactly same, which means we have found our optimal solution, and we can say that currently one of the permutation of string 1 is actually present inside string 2. So we can return true as the answer in this case. And in case, say for an example, this one was not B and this one was something else like character D. So the moment we reach to this value and we have a string that looks like D1, something like this, then there is no longer a window possible for us to move forward, which means we have exhausted every single possibility in string 2. Still, we did not find the same set of frequency of character present inside the string 1, which means we can simply return false in that case. And this is the whole approach. So this would be the optimal solution. If we see time and trace complexity in this case, the time complexity complexity is very simple. It's going to be big O of n, because number one, in order to create this hash map, it takes us big O of n time, and then using a sliding window, we simply have to iterate over this given array. So this is also big O of n. In terms of space complexity, so this can be big O of 1. Why? Because we know that there are only 26 characters inside the alphabet. We are not dealing with any special characters or any extra elements, which means there is only a finite number of characters we can store inside our hash map or frequency maps. So that's why space complexity is going to be 1. So this is a very good time and space complexity, which yields us very good results. So now let's quickly see the coding solution for this one. So first of all, we are going to check that if the given string 1 is actually greater than string 2, which means we can directly return false. If that is not the case, we are going to initialize two arrays with the size 26, which we are going to use as frequency maps. Then we are going to initialize the frequency map for the string 1 and also for the first window of string 2. And the first window of string 2 is going to be the length of a string 1. Okay. Then we simply have to slide the window through S2 and compare it with the frequency map of string 1. If both match, then we can simply return true. If that does not match, we are going to keep on updating the window of the given string, which means we are going to drop off the left side of the element and we are going to add the right side of the element. And then we can once again keep on repeating the same process until the very last window. If we do find that there is a match, then we can simply return true. At any given moment, we find that we are able to reach to the very end, then we can simply return false. And we are creating a helper function to compare the frequency of two maps, which is going to be just running for loops across both the arrays and check that at any given moment, whether the frequency is deviating away from a single character or not. And then we can simply break out of that loop. Okay, so let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs extremely fast in terms of time complexity and also very efficiently in terms of space complexity. So you can find this code in our GitHub repository and the link is in the description. Thank you.
Hello friends, we are not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do longest repeating character replacement lead code problem that contains very important properties related to string based problems. If we see the companies where I want to get a job and that have already asked this question, there are companies like Google, Amazon, Uber, Adobe, Facebook, Apple, Bloomberg and Microsoft. So some of the top tier IT companies. So that's why I am paying my utmost attention. I hope you also enjoy the video. So this is the lead code medium problem, and basically we are given a string s and we are given an integer k. Now we are told that inside this given string s, we can replace any character with any other character in the English language, and we can repeat this operation k times. Now, after repeating this operation, what is the main purpose of this question is that we need to return the length of the longest substring that contains the same letter by doing this replace activity, and we need to return that length. Okay, so now we will try to understand this problem with this example. So suppose we are given our s is equal to a, b, a, b. And we are told that k is equal to 2, which means we can replace any two character with whatever two characters we want. So in this case, we have two options. Either we replace these two b's with value number a, then we will get a string that looks like a, or we can replace these two a's with the letter b, and then we will get a string. Our concern is we don't care what is the value of the string. Our aim is to find the longest substring that contains all the repeated character, and we need to find the length of it. In both the cases, the length of these two is actually 4, and this would be the answer we need to return. So this is what the problem is asking us to do. Let's take one more example to make our understanding more clear. So suppose our given s is equal to HP. If this is the case, and our given k is equal to 2 again in this case. So now if we see the options we have, we can replace like these two p's with the value h. So that will give us a string like h. And so if we see the longest substring that contains the same letter, the length in this case becomes 5. Second option we have is that we choose any two h value, suppose these two, and we replace it with value number p. If we do that, we will get a substring that looks like this. So in this case, if we see that what is the longest length of the subsequence that contains the same letter, it's actually 4. So this is 4 and this is 5, and we need to return the longest. So that's why this is the most optimal way to approach this problem in this case, where we are going to replace these two p values with the letter h, and we don't do this p operation. So there are few ways to solve this problem, and there is also a brute force way to solve this problem. So first I'll show you the brute force way, and then we will see that what would be the optimized approach. First of all, we identify that what is the thing that we want to find. We want to find a substring, and then we want to replace the characters, and then we want to find a substring that contains the longest length with the same characters, right? So first approach we can take in the brute force is that we take every single substring that is possible. So even if we just see that substrings that starts at A, we will get substrings like A, B, A, B, A, and A, B, A, B, something like this. Again, if we see substring that starts with B, we will get B, A, B, A, B, and so on and so forth. So we would end up with bunch of different substrings. Then we will start this replace operation on all the substrings, and eventually we would find some substring that will look like this A, or this B, 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 B. And in any case, we would be able to return the length as 4. Like, okay, this solution would work and we will get the desired result, but there are a lot of issues with that. Even if we just see that for a single character, we end up with like so many substrings, and we still have more substrings to go to. So this is a very inefficient approach, and we should avoid doing it at all costs. Okay, before we come up with the optimal solution, first of all, we will have to identify that what is our need. Our need in this case is that we are given this string, and we are told that we can replace any two characters inside this given string with any other characters because k is equal to 2. Now we need to find a substring where all the characters contains the same value, and because they contains the same value, we need to return the length of it. So first of all, we will have to identify that what is the substring where we can actually create all the characters of the same length. So first of all, let's see that can we apply this thing on this whole substring for this entire string of all the 5 characters, and this given k is equal to 2. So first of all, we will try to identify that what is the number of occurrences of every single character. So a occurs 2 times.